Hi, this is Maggie. In this video, I'm going to introduce the idea of regular expressions and how to write and use them in Java. I don't have an excellent free online resource for you for regular expressions. The best book that I have ever read on the subject is called Mastering Regular Expressions by Jeffrey Friedel, and I recommend it highly. I'll include a link in the description. In an earlier video on splitting strings, which I'll link here and in the description, we learned that to use the string.split method, we pass in a regular expression as a delimiter. Because a literal string is a very simple regular expression, we passed in a string composed of a single character as our delimiter. That is one use of regular expressions. But regular expressions are used for general text processing, and they are much more powerful than simply matching a single character. Regular expressions are used to find pattern matches in text and can be written in a very general way. So, for example, they can be used to determine whether a string is a match for any form of phone number a person might enter, or they can be used to remove HTML tags from a document, or to find something in a particular format in some text, like a 16-character code in which every 4 characters are separated by dashes. Let's start by writing some regular expressions in a free online tool, and then we'll take what we've learned and apply it in a Java program. This is Regex101.com, and it allows me to write a regular expression, choose the language that I'm writing the regex in, and then apply the regular expression to some text. Let's begin with a few examples, and then we'll talk about some of the constructs that are available, and then some strategies for writing regular expressions. That's a lot, so let's get started. We'll begin with the simple one-character regular expression from the string splitting video. In that video, we were looking to split a string on a / character, and the string contained 2, splitting the string into 3 pieces. Here I've typed the / in the regular expression text entry area. I've chosen Java 8 as my language, and I'm going to paste in the "there is no believing a liar" proverb string, which has 2 / in it, into the test string area. And immediately on the right side in the match information area, we can see 2 matches, and the position, indices 60 to 61 and indices 89 to 90. This is the very simplest form of regular expression, a literal string. I could search for a multi-character literal string. For example, why don't I type liar in the regular expression box? And now we can see in the match information area the 2 matches for the word liar, written exactly as I've written it here, all lowercase letters. In addition to matching literal strings, there are special constructs we can include in the regular expression that will match different categories or amounts of characters. So let's do one example illustrating that, and then we'll talk about what constructs are available and how they work. So now I'm going to paste in for the test string the HTML for the Wikipedia page on regular expressions. Let's write a regular expression that will find all of the HTML tags in the document. An HTML tag begins with an open angle bracket. Let's type that. And there are over 9,000 matches. If we look at a few, we can see that some are start tags and some are end tags. And some have attributes like this link tag with the rel and href attributes. There is a wide variety of content that can go between the open bracket and the close bracket. So we need to look for an open bracket and then some text and then a close bracket. So let's try to use some of those special constructs to get what we want. Let's try period, which will match any character, and then star, which will match any number of characters. So together they mean any number of any character. That means the regular expression will match an open bracket, any number of any character, followed by a close bracket. Let's see what that yields. Okay, and at first glance that looks good. We can see highlighted areas in the test string that start with an open bracket and end with a close bracket. But look at the second match. It's open bracket, HTML, through the close bracket, and then open bracket for the head tag until the close bracket for the head tag. So that includes 2 tags, not 1. It's including open and close brackets in what it's accepting as long as they're all on the same line. That period, meaning any character, includes open and close brackets. So any character isn't going to work. Is there a way we can subtract out characters? Let's look at the oracle.com documentation for pattern. And we see in the section called character classes, we can see the caret means negation. The first example in square brackets is ABC. That will match A, B, or C. The second example in square brackets is caret ABC, and that's any character except A, B, or C. That seems like just what we need. Let's replace the period with open square bracket, caret, and then our angle brackets, close bracket, asterisk. That should be any character except the open and close angle brackets. So looking at the matches, we can now see that it's finding the individual tags, including whatever attributes are within the tags, but it's not combining tags and counting 2 or more tags as 1. Okay, so those are some examples, and you'll notice that Regex 101 does give you a lot of information, such as describing over in the explanation area what each piece of the regular expression is doing. But let's look at some of these different constructs in the Oracle pattern documentation to see what tools we have available to us, and then let's talk about strategy for writing a regular expression with another example. Okay, so first we have some escape characters. As you already know, any literal character or sequence of characters will match itself. But then the backslash character precedes some escape sequences. So if you want a literal backslash character, you'll need to escape it with a backslash character. And then other characters you might want to match, such as newline, tab, etc., have the escape sequences you're probably used to. You can also define characters by their code points. The next category is character classes, and this allows you to match categories of characters. Classes are enclosed in square brackets, and it's very important to know that the meaning of some special characters is different within the square brackets when defining a class versus outside of the square brackets. So even though they're both part of a regular expression, they have completely different syntaxes. Remember that. So inside the brackets, if you list characters such as this, open bracket ABC close bracket, it means match one of these characters. So that's a match for A or B or C. If you want to match any one character that isn't A or B or C, then use a caret inside the class. We just did that to prevent matching angle brackets inside an HTML tag. The caret is a character that has a different meaning inside a class versus out, so it only has that not meaning inside a class. As a shortcut to listing characters, you can use a dash inside a class to indicate a range of characters. Now let's skip down to predefined character classes. As I mentioned at the start of this video, there's an excellent book on regular expressions that I highly recommend. There is a lot to these, and they take practice to master, so we won't be discussing everything. Okay, some character classes are so common that there are escape sequences for them. The period, or dot, matches any one character. And then you can see there are predefined sequences for a digit or anything but a digit, a horizontal whitespace character or anything but, a word character or anything but, etc. And then let's look at the greedy quantifiers. The question mark after a character or group, which is enclosed in parentheses, means 0 or 1. A plus means 1 or more. An asterisk means 0 or more. You can also use curly braces to specify an exact number of repetitions. Okay, let's work with that. Let's build a regular expression that will recognize an arithmetic expression using integers, addition, and multiplication. A good first step is to list out examples of strings that should succeed, and then also strings that should not succeed. Because there are going to be an infinite number of strings that shouldn't succeed, we will restrict that list to strings that are similar to what will succeed, but wrong. So places where the regular expression could be close, but not quite right. So here I have a list of strings that should succeed. I wrote this by writing out some examples and then categorizing them so that I could think about them more generally. Now, it doesn't mean I'm going to use the categories when I write the regular expression. But writing a lot of examples helps me find special cases, and it helps me understand what I need to allow for each position in a string matching a regular expression. So here I have categories for single-digit integers and a single operation, either addition or multiplication. And I have categories for multiple-digit integers and a single operation, and for mixed single and multiple-digit integers. And then I could have multiple operations. Now, how much space should I allow between digits and operators? I should probably allow no space up to any amount of white space, but of course, no other characters. So a failing string would be a string with a non-digit, non-plus, non-asterisk, non-white space character in it somewhere, like 56A plus $2. Another failing string would be a string with a plus sign or multiplication sign at the end of the string, like 56 plus. I don't want to allow decimal points because I'm not allowing real numbers, so no strings like 3.5 plus 2. I probably should allow a negative sign before a number, such as -5 times 23, but I'm going to leave that as an exercise and consider it a failing string here. I might think of additional succeeding and failing strings as I proceed, but let's start with this. Now that I have a good number of strings to look at, I can start writing the regular expression, and I'm going to write it left to right in the order that it will be matched to a string. Now, there's a really cool tool called Regex Beta, and unfortunately it doesn't have a Java category. But since Java and JavaScript regular expressions are very similar, I'm going to use that to build this regular expression because it offers a very good visualization of the regular expression. So, working on our regular expression from left to right, notice that a successful string always starts with an integer. And an integer can be represented as one or more digits. So let's take a first stab at a piece of a regular expression to represent an integer. Let's start with the class of digits 0 to 9, one or more times. I type the regular expression into this first box. So open square bracket, 0-9, close square bracket, plus. And the string I want to match below, and Regex shows me if the string matches or not. There's also a visualization which starts at the black circle, and then you follow the paths through the regex visually. So I can have one integer digit, or I can have many integer digits. There's no path that bypasses an integer digit entirely, so the empty string does not match. Now, you can see that this allows for an infinite number of zeros as an integer, as well as other integers that are technically fine, but not how we usually write integers, such as 007. Can we fix that? How about this? We can allow 1 0, or we can allow one non-zero digit followed by any number of the digits 0 to 9. We write that as 0 and then a single straight line for OR. And then the other argument to the OR I'm going to enclose in parentheses. Square bracket 1-9, close square bracket 0-9, close square bracket, asterisk. If you look at the graphical representation, you can see that I can write 1 0, and there is a path start to finish with that 1 0. Or I can follow the other path and have one digit 1 to 9, or one digit 1 to 9 followed by any number of digits 0 to 9. And if I test it on 1, 0, notice the circle at the end lights up red. But if I type multiple zeros, it doesn't. And there's a red underline in the test string where it fails. I think I'll go back to my what I'll call specifications document and add the more than 1 0 integer as a string that should fail. Now this started as a really simple looking regular expression, but to exclude cases that should fail, it's become quite complex. I'm pointing that out because when you look at a regular expression that somebody else has written, it can look quite intimidating, but you can see how they get that way. And if you understand what each piece is and take it one little piece at a time, you can build better expressions and also understand complicated expressions. So again, that doesn't allow for a plus sign or minus sign at the start of the integer, but I'm going to leave that as an exercise. Now I'm wondering if I should allow an integer and nothing else. Does an integer fall into the category of an arithmetic expression using integers, addition, and multiplication? I think it does. So I'm going to add a just integer category to successful strings. We'll get back to that later with a quantifier. I've put parentheses around this entire expression. By the way, I throw parentheses around like they're nothing, but parentheses, or grouping, actually causes some overhead in a regular expression, because what matches each set of parentheses is stored. We're not going to worry about that, but I wanted you to know, and you can see the parentheses labeled as groups in debugX. Alright, so I want to allow any amount of white space between this digit and either a multiplication symbol or an addition symbol. I think I can write the character class backslash lowercase s, which is white space, followed by an asterisk. So that will be successful for no white space or any amount of white space. And then I'm going to write the character class containing plus and the asterisk because I want to require either a plus sign or a multiplication sign. Now remember that those have syntactical meaning outside of a character class, but inside a character class or square brackets, they're literals. I cannot end with the plus or the asterisk. I must have another digit after this. Let me copy and paste my digit group or expression after the plus and asterisk class. So now if I test it a bit and I type in 5 space asterisk space 8, I realized that I forgot to specify any amount of white space between the asterisk and the next integer. You see how these get long and complex. Let me copy paste that in there between the plus or asterisk and the next integer. Oh good, that simple expression is correct now. Let me try some of my longer integers like 5004 times 8. And that succeeds. And let me remove the white space and put in a lot more, like some tabs, and it still succeeds. But if I try to put plus 9 on the end, that part of the expression fails. So I'm allowing only for one operation. What part of this regular expression do I want to quantify, and how to allow for multiple operations? I want to allow for a single integer, but then after that, any number of operations with additional digits. Each operation must be followed by a digit. So I'm going to enclose from the first whitespace class through the end of the expression as a group in parentheses and put an asterisk after it to allow for 0 or more additional operations. And now my expression with 2 operations succeeds. But if I add an asterisk at the end, it fails. And if I add different characters inside, such as the $sign or a letter, it fails. And now again, maybe you'd want to extend this to allow it to accept a hexadecimal number or an octal number or a binary number. I leave that as an exercise for you. I will also leave it as an exercise to continue testing it on the strings that should succeed and the strings that should fail, and perhaps find a special case that I haven't accounted for here. In general, I think this process of first looking at what should be allowed and what shouldn't, followed by slowly building up the components of the regular expression to consider and match or fail each possibility at each step, left to right, is a reasonable process for creating a regular expression. Now let's implement this in Java. In Java, we're going to use two classes, pattern and matcher. I'll create a new class and import java.util.regex.star. The pattern class is used to store your pattern and can be used to generate a matcher object. So we'll define pattern p equals pattern.compile, and then let's pass in our regular expression to match HTML tags, and we pass that in as a string parameter. Now, once we have that, we create a matcher object. Matcher m equals p.matcher. And I'm going to pass in the string that I want to find matches in. I'll just pass in the top of the Wikipedia document. So the matcher is something that applies the regular expression pattern to a specific string. We could create as many matchers as we want for different strings using our one pattern object. Let's look at the documentation for matcher on oracle.com. It says, once created, a matcher can be used to perform 3 different kinds of match operations. The matches method attempts to match the entire input sequence against the pattern. The looking at method attempts to match the input sequence starting at the beginning against the pattern. The find method scans the input sequence looking for the next subsequence that matches the pattern. So the matcher can see if an entire string matches your pattern, or the beginning of the string, or it can find all occurrences within the string. Let's find all occurrences. If we look through the methods, we see find, which says attempts to find the next subsequence of the input sequences that matches the pattern, and that returns a Boolean. There's also group, which returns the input subsequence matched by the previous match. And then there's start, which returns the start index of the previous match. Let's use those 3 methods. But if you look through, you can see there are a lot of different ways we can get at the matches. So we'll write while m.find, and then system.out.println, m.start. That will give us the start index of the match, and then we'll concatenate a colon and some space. And then we'll concatenate m.group, which will display the match itself. And let's run that. And we can see 7 matches for this particular string, and we can see what they are: doc type, open HTML, head, 2 meta tags, and open and close title. So that is an introduction to regular expressions in Java. They're very powerful, and really with some practice, you'll get quite good at them, and you'll wonder how you ever programmed without them. One caveat: as a general rule, if a language has a dedicated method or function for doing some string processing, use that dedicated method or function instead of a regular expression. Regular expressions aren't generally efficient, and you might make a mistake that is probably not present in a well-tested language library. And maybe one other word of advice: make sure you understand your input strings really well before you write a regular expression, so that your regular expression is exactly as general as it needs to be. If you overwrite it, it might be overly complicated, difficult to read, and more prone to error. And if you underwrite it, well, it won't work on all inputs. There is a practice exercise in the description of this video that will allow you to write some of the regular expressions we've written here. I recommend you practice with the exercise, and then think about regular expressions that might be useful to you, or that might commonly arise, and write those. In Regex, you can see a list of unit test libraries, which can give you some ideas for things to try, like dollar value, real number, number up to 255, etc. Try solving some of those problems. Once you can do that, you're ready to move on.